Good morning. This is your stat sensei, Mr. Spensei, and this is a solution video to the classical probability quiz. So, the first question is, what is the probability that a family owns a dog? Well, dog is this entire circle right here. So the probability of a dog is 0.26 plus 0.13, and that's the probability of a dog. And so that equals 0.39. So our answer is 0.39. What's the probability a family owns neither a dog nor a cat? Well, neither is the outside area. That's the area around it that's not included. And the area that's not included, we'll need to make a box for. Pen just ran out. Anyway, so we're looking for this area out in the box. Well, to do that, we're going to go 1 minus the 0.26 plus 0.13 plus 0.21. So we're basically subtracting the figure 8. So let's add those up. 0.26 plus 0.13 plus 0.21 equals 0.6. So 1 minus 0.6 equals 0.40. So let's check that out real quickly. Let's add up all those numbers and make sure they actually add up to 1 to make a valid probability distribution. So 0.26 plus 0.13 plus 0.21 plus 0.4 adds up to one whole. Looks pretty good. Given a family owns a cat, what's the probability they also own a dog? So basically, we're intersection over given, but they're being tricky here. Given they own a cat, well, cat, first of all, we need to know the probability of a cat. The probability of a cat is that circle. So down in the denominator, we really have 0.21 plus 0.13. And then our intersection is where the two cross, and that's this part right here. That's the probability of both, is 0.13. So we end up with 0.13 over 0.34 when we add those together, because the probability of a cat is 0.34. So a survey of families revealed 74% of the families eat turkey at a holiday meal and 32% eat ham and 21% eat both ham and turkey. All right. Um, Create a Venn diagram for the above situation, being certain to demonstrate how families may have neither turkey nor ham. All right, so we're going to need to show all of our work. Well, first off, they tell us this is the probability they eat both. Well, both is the intersection, so this is 0.21. And I'm going to label this one turkey and this one ham. Well, turkey, they said 74%. So this is going to be 0.74 minus the 0.21 because we have to subtract out the overlap so it doesn't count twice. So 0.74 minus 0.21 is 0.53. So this area right here, the turkey, is 0.53. Ham, on the other hand, they said was 32%. So this is going to be 0.32 minus 0.21. And when I subtract that, I get 0.11. So basically, the probability they eat one or the other is the sum of these. Or in other words, I could have gone the probability of A union B equals the probability of A plus the probability of B minus the intersection. And I'll just use the intersection sign. Well, we know that the probability of A, the turkey, is 0.74. We know the probability of the ham is 0.32. And we know the probability of both is 0.21. So when we add those up, we 0.74 plus 0.32 plus minus 0.21, 0.74 plus 0.32 minus 0.21 equals 0.85. So this, the probability of them eating one or the other or both, that probability is 0.85. Well, if I go 1 minus that 0.85, I'm going to get 0.15, and that should be the probability of eating neither. So let's add up all these values and make sure they add up to 1. And yes, there's more than one way to go about this. 0.53 plus 0.21 plus 0.11 plus 0.15. That equals one whole. Looks like we have neither correct. All right, so all of this looks pretty good. If A equals 0.55 and A intersects B is 0.42 and A union B equals 0.4, then what is B? Well, in this case, I need to go back to the A union B formula. So I have probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. And they're telling me union B is 0.4. They're telling me that A is 0.55. We don't know B, so we'll just put a B in there. And what we do know, the intersection is 0.42. Well, I can subtract the 55 and the 42, and now I have 0.40 equals 0.13 plus B, because I subtracted the 42 from the 55. If I subtract 0.13 from both sides, I end up getting 0.27. So B equals 0.27. All right, and I can check that out. Let's add these up. 0.55 plus 0.27, that's what B is, minus 0.42. And that equals a 0.4, so it looks like we did it correctly. All right, next problem. Suppose 40% of cars in your area are manufactured in the United States, 30% in Japan, 10% in Germany, 20% in other countries. If a car is selected at random, find the probability that the car is made in Japan or Germany. So let's add these up real quickly. So we have 0 0.4, 0 0.3. You know what? Let's make this a little easier to work with. So USA is 0.40. Japan is 0.30. Germany is 10%. And I'm going to put O for other is 20%. Let's add up all those numbers real quickly, make sure that they add up to one whole. So 0.4 plus 0.3 plus 0.1 plus 0.2 adds up to one whole, so we're good to go. So what's the probability the car is made in Japan or Germany? Well, that's just 0.3 plus 0.1 equals 0.40. Two cars in a row are from Japan are selected. Okay, so blank blank, the probability from Japan is 0.3 and 0.3 or 0.30 doesn't matter. And when we multiply 0.3 times 0.3, we end up getting 0.09. None of three cars are selected from Germany. So basically, we're selecting three cars, one, two, three, not Germany, not Germany, not Germany. Well, the probability of not Germany is going to be 1 minus 0.10, which is 0.9. So this is 0.9 times 0.9 times 0.9. 0.9 raised to the third power, or 0.9 times 0.9 is 0.729. At least one of three cars selected is US made. All right. So this is one of those hard problems. Anytime it's at least one, we're going to have to do one minus. Well, that means one minus what they're asking for. Well, what they're asking for is from the US. So we're going to go 1 minus 0.4, which equals 0.6. So we're going to say, hey, what's the probability that none of the cars are from the US? So that's going to be 1, 2, 3. 60% are not from the US. 60% are not from the US. Put a little time sign in between there. Close that up. And we have 0.6 raised, 0.6 raised to the third power. And we have 0.2126 or 216. 1 minus 0.216. That 0.216 is none are from the US. The probability that at least one would be 1 minus that, and we get 0.784. So if you have three cars, there's about a 78% chance that at least one of them is from the US. The first car, the first Japanese car is the fourth car selected. So one, two, three, four, not Japanese, not Japanese, not Japanese. And then we have Japanese. Well, the probability of Japanese is 0.30. And then these are not Japanese, which is 1 minus. And if I go 0.7 raised to the third power and then multiply it by 0.3, I end up getting about 10%, 0.1029. Please remember to always go 4 decimal places. All right. The next is, what is the expected number of calculators sold? Well, that means I'm going to need to drop this into L1 and this into L2. So let's do that. Stat edit and clear some stuff out. So I end up having, I'm in stat edit and I press 2,000, 5,000, 10,000, 20,000. Oops, 20. All right. Now, my probabilities 0.1, 0.2, 0.3, and 0.4. Stat calc, one variable statistics, blue button 1, blue button 2 for the frequency. So L1 and L2 are on. Calculate, and we're looking for our X bar, and our X bar is 12,200. 12,200 calculators. All right. The next thing, complete the table and find the expected value. Well, I need this to add up to 1. So 1 minus 0.25 plus 0.15 plus 0.1 plus 0.2. So let's do the inside the parenthesis first. 0.25 plus 0.15 plus 0.1 plus 0.2 is 1, and then 1 minus that is we get 0.3. So this should be 0.3. Let's check our workout real quickly. All right. So 0.25 plus 0.3 plus 0.15 plus 0.1 plus 0.2. That adds up to one whole. Looks good. Now we have that. We'll go to stat edit. We're going to enter this information. We're going to clear that out. And we have 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. And we have 0.25, enter, 0.3, enter, 0.15, enter, 0.1, enter, and then 0.2. Stat calc, one variable statistics, blue button 1, blue button 2. And we have an expected value of 1.7. Remember, that's just your X bar. Expected value, average, mean are all the same thing, X bar. And then we need our standard deviation, which is this symbol. And it says 1.4525. 1.4525 is our standard deviation. All right, continuing on. Without reading the thing, it says if one of the flights is selected at random from the airport in January, what's the probability the flight selected will have at least one of the two types of errors? Well, that's difficult. So I can do one of a couple things. I could add up these, but the easiest thing is go 1 minus the opposite of what they said. So this would be the probability that they have 0 delays, all right? Because that's no mechanical, no ice. So that's probability of 0 delays. So 1 minus 0.665 equals 0.335. Alternatively, I could have added up this, and this, because this is having 1 delay, this is having 2 delays, and this is having 1. So this is having a mechanical and ice, so there's 2. This is ice and no mechanical, that's 1. This is no ice but mechanical, so that's also 1. All right. What's the probability that a randomly selected flight has exactly one delay? Well, we kind of just got to that. We said, oh, this has a mechanical delay, but I mean, has an ice delay, but not a mechanical, so it only has one. This one has no ice, but a mechanical, so it has one. So what basically we're looking for is these two that have one, so we need to add them up. So 0.27 plus 0.035 is 0.305. All right, given that a flight had a mechanical delay, what's the probability that it also had an ice delay? So once again, this is an intersection over given. And what were we given? Well, we were given they had a mechanical delay. So that's 0.065. And the probability they had an ice delay is that intersection, which is 0.03. So 0.03 over 0.065 equals 0.4615. If you left it as a fraction, I would give you full credit. All right, the table. A laboratory test for the detection of a certain disease gives a positive result 5% of the time for people who do not have the disease. Ooh, positive and has the disease or do not have the disease. So this is positive and do not have the disease. That one has two. The test gives a negative result. So negative 3% of the time for people who have the disease. Oh, this also looks like it's two variables. Large scale studies show the disease occurs about 2% of the population. Oh, that's disease only. So that's my single variable. So that's what I'm interested in. So this right here is 2%. Please remember, guys, that always take percents and divide them by 100. So 2 divided by 100 is 0.02. So if this is 0.02, this is going to be 1 minus 0.02, which is 0.98. Now, we just said this is the 2% is for those who have the disease. So D for disease, ND for not disease. And then we have test results that are positive and negative. Now, because this is a small number, I'm going to write it small. I'm going to bring this number up and write it small. Not because it's a small number, but that's just part of our what we have to do. And I'm going to write this small as well. Bring it up and write it small. All right, now I need to go back, and we've taken care of the 2%. So a positive result 5% of the time. So positive results, we're looking at this. This is the positive result 5% of the time for people who do not have the disease. Oh, no disease is 5%. Well, that's going to be 1 minus, excuse me, 1 minus 0.05 is going there. So let's go ahead and multiply those out. When we do that, we have 0.98 times 0.05. 0.98 times 0.05 is 0.049. And then we're going to do 0.98 parenthesis 1 minus the 0.05 and close those parentheses. And we get 0.931. Let's add up those two numbers, make sure that they add up to 0.98. So 0.931 plus the 0.049. Oh, that equals 0.98. So I feel pretty good that I probably did that correctly. All right. The test gives a negative result. So now I'm looking at this negative row. In about negative result 3% of the time for people who have the disease. Oh, so negative and has the disease is right here. So now, because we're looking at this row, this column and this row, because negative result have the disease, then this is going to be 1 minus 0.03. So we have 0.02 parenthesis 1 minus 0.03, and that gives us 0.0194. And then we have 0.02 times 0.03, and that gives me 6e to the negative 4, and I know that scares people. So here's what that means. My calculator says 6e to the negative 4. All right, so I'm going to put a decimal point right here. It'll always go right there. And because this is a 4, I'm going to go 1, 2, 3, 4. And I'll put 3 as 0 every single one place I don't have a number. So 6e to the negative 4 is just 0.0006. So this is 0.0006. If I add up those numbers, 0.0006 plus 0.0194, it adds up to 0.02. So I feel pretty good about that. Now we need to add across. So 0.0194 plus 0.049 equals 0.0684. This is 0.0006 plus 0.931. That equals 0.9316. All right, I should be able to add up these two numbers, and they should have to add up to 1. So let's check that out, make sure that's worked, that we did everything correct. So 0.0684 plus 0.9316, that's 1. So if I look at this, adding this way, I get 0.2. Adding this way, I get 0.98. Adding this, I get this, this, and this plus this is this. I feel pretty good that the table is done correctly. And so we have disease and no disease. All right. Thank you for watching. I hope this helps. I hope you study for your test. Talk to you later.